Up next, we have our co-chairs. Our co-chairs are going to help folks out with a recap of our past year of accomplishments. So I'm going to make these settings correct and also invite our Working Group 1 co-chairs up. All of our co-chairs can come and take a seat at the next speaker table. Okay. So our first co-chairs are from Working Group 1. We have Dimitri Contoyannis, Neal, Kruis, and Supriya Goel. And they are in charge of, I guess, experts in our streamlining building energy modeling group. Thank you.
Morning, everybody. We're going to start with a very quick recap of 2025 Working Group 1 activities. Working Group 1, if you've never participated, we focus on opportunities to streamline compliance processes, ways to make your lives easier as compliance analysts. So if you're looking for a group to join today, please join ours. It's always an interesting discussion. I'd say that, the highlight for me anyways, in 2025 were the cross-pollination sessions. I think the fact that we were able to share thoughts amongst the 3 different working groups was very successful, and hopefully we can continue to do that in the future as well. I will say that, starting with 2024, about a year ago, we identified 2 big priorities. One, aligning the energy code with building performance standards through predictive modeling. And this is something we will plan to continue discussing during tomorrow's breakout session. Again, hopefully you can join us there for an interesting discussion. Another priority that we've identified, which I'd say we didn't make a ton of progress in 2025, was the supporting of the development of machine-readable rule sets. In other words, a way to write the energy code in a way that computers can understand it, never mind humans, which we all struggle to do sometimes. In 2025, again, we really focused on the cross-pollination sessions, but a couple highlights that I'd like to share is that we had a couple of CalBEM funded projects. At the very beginning of 2025, we gave a presentation on a project led by Greg Collins, Zero Envy, on a analysis of the Title 24 ACM methodology compared to the ASHRAE 90.1 PRM methodology, and understanding of how some of the additional knobs you have to turn within PRM create some variation from ACM-based analysis. There's another interesting project that they're working on, Zero Envy is working on this year. There'll be a power talk later on today that we're all really looking forward to on data visualization of compliance analysis results so that you can have a better understanding of how the building model is performing as opposed to the kind of static PDF reports. So definitely looking forward to that as well. Now I'm going to hand it over to Neal, my co-chair, to discuss one of the cross-pollination webinars. Thanks.
All right, thanks, Dimitri. So each of the working group is going to kind of recap one of the cross-pollination webinars that we had. Ours was a webinar on equipment modeling. And so we started with a presentation by Haile Bucaneg from the California Energy Commission. And he kind of just explained really some of the reasons behind why the commission has chosen to go on a path of generic performance versus product-specific performance, and some of the challenges that are associated with trying to incorporate product-specific performance into the compliance analysis. The second presentation was given by Luke Morton and Nick Brown, specifically on heat pump water heaters, because this is the one area really that uses product-specific performance in the compliance software. They showed that especially for residential homes in specific climate zones, domestic hot water, energy use, and long-term system costs are actually highest for that specific end use for domestic hot water, and so it's becoming a more important component. And then they compared the product-specific performance across a few products and then compare them also to some of the generic performance. I'm not going to get into the details here, but if you want these, there are videos, recordings of this webinar. And then I followed up with a presentation just kind of going over what, if we do use generic performance, what does that leave on the table? What opportunities are we missing? One of the big takeaways and one of my big bullet points is when we use seasonal efficiency ratings for building energy modeling, they're really not intended for that purpose. They're designed for specific climate zones and kind of a lot of assumptions that aren't going to apply to the actual buildings where the equipment are going to be applied. And so there is really some need to try to get better product-specific performance. And I also gave a plug, and probably not my last plug, for ASHRAE Standard 205, which is enabling standardized data transfer from manufacturers to building energy modeling in order to model specific equipment. So with that, I'm going to hand it off to Supriya, who's going to go over our preview for our breakout sessions during this symposium.
Thanks, Neal. So for our symposium, today and tomorrow, we have quite an interesting agenda. Today, we're going to start off, as you all know, we meet after lunch, and we're going to start off with some project updates. So there is an update from Noresco, where Sally will be telling us about, which was previously a CalBEM project, and then a DOE-funded project on expanding energy code expertise through third-party reviews. And there's an EBIPSA USA and CalBEM initiative on BEM data exchange, which Neal and Greg will be talking about. And then we're going to just have some discussion on, future for that work, where we see additional needs and how we can develop it further. We're going to have a more in-depth discussion on leveraging AI for codes, and we'll walk through all processes from code development, code adoption, implementation, code checks, and then finally, when a building is an existing building and you have a large amount of data, how AI can support the next steps of benchmarking, retrofit assessment. And we'll talk about what capabilities exist currently in the industry to support each of these steps and how this can be developed further, which are some gaps, and where there are inroads being made by industry. For breakout session 2, we'll talk about California's Building Energy Efficiency Standard and transitioning from code checking, modeling for code checks, to more predictive modeling. What kind of capabilities are needed? Erik gave us a great overview of how we need to think about panel upgrades, electricity capacity, and aspects which actually relate to electrification. So where modeling can play a role is something we want to discuss further. And then some open-ended discussion on the future of Working Group 1, areas where we see ourselves growing into, so we kind of welcome input from everyone. So hope to see you there.
Two men who need no introduction, Working Group 2 co-chairs, Nick Brown and Erik Kolderup.
Thank you. I'm Nick Brown. I'm a BEM practitioner and an Energy Code ACE instructor. Working Group 2 is going to be in the back of the room here today, so join us. We are a small but mighty group. So our working group sessions lend themselves to a lot of brainstorming and roundtable. We're focused, as I said, on resources and educational offerings. So we end up getting involved in workforce development issues, improving model accuracy. And I think we put the mighty in because we're responsible for more actual projects to come out of CalBEM sessions than the other two working groups. Last year, the problem statements we identified that we've been working on since, it was hard to design the educational resources needed by the industry if we didn't understand the key knowledge, skills, and abilities needed to be a BEM practitioner. So that led to a January webinar that probably many of you attended. Similarly, it was hard to understand workforce development challenges without understanding what the career paths are, what typical salaries are, and the joy of being a BEM practitioner. So a proposal was submitted to the steering committee for consideration on quantifying BEM employment opportunities. We'll continue to discuss both of those over the next couple of days. There's a couple of projects already in motion that have been born in our working group. The BEM Career Pathways Initiative, with which I've got a couple of slides coming up here in a minute to give you a preview of, thanks to A2 for leading that effort. Greg Collins' project on quantifying and visualizing BEM data mentioned earlier, and that quantifying BEM opportunities proposal. So this Career Pathways project, I think in some ways I'm most excited about personally. We use the analogy of junior achievement when professionals go into classrooms and talk about the importance of economics. In this case, this is that concept for BEM, where the project team would develop some content that professionals like all of you could go to your local high schools and colleges and present about BEM so that those architecture and engineering grads have a better grasp of our field, because it's largely unknown, isn't it? So that's the concept, and I think A2 will be looking for input from all of you as they continue to work on this project, and looking for people interested in being guest speakers. Erik?
Hi, Erik Kolderup. Very happy to be here. All right, so we're reporting on this cross-pollination meeting that happened in April on AI in CalBEM. So exploring applications of AI in BEM processes, tools, and education. So obviously a relevant topic for our discussions over the next couple days. So we heard from Tianzhen Hong of LBNL and Professor Liang Zhang, who's here today, from University of Arizona, who's also going to be talking a little later today. Tianzhen gave an overview of AI and also touched on some of the applications of AI in BEM, things like using it for large-scale simulations, for existing buildings, gathering data to represent existing buildings, and so on. And as Neal noted earlier, there are recordings of these webinars available in the CalBEM website. And he also touched on challenges of using AI for BEM, things like identifying the right models fit for purpose, data needs for training and validating these things, transfer learning, so taking models from one building and using them for another, explainable actions, benchmarking data sets and performance metrics, how do we know if these things are working right, and then of course those warnings there at the end. And then Professor Zhang talked about large language models, how are they suitable for BEM, how to use them effectively and reliably, what are some of the existing tools that we can use for these applications, and then two interesting case studies. The first one was this agentic workflow to automate Energy Plus IDF file generation. So actually, using prompts to create an energy model, that's an area of people are doing work and it's very interesting. And then the second, more kind of on the education resource side, fine-tuning a foundation model to learn Energy Plus documentation. So creating a system that would allow you to prompt and ask questions about, how to do energy modeling. So I think that's really interesting. So a pitch for joining us today and tomorrow in our breakout sessions. Two compelling reasons. One is you don't have to find another room. We're going to be right back here in the back of the room. So, those other places are who knows where, on some other floor. You have to pass a bunch of other conferences to get there. Sounds like a really scary prospect to me. I suggest stay in this room right back there. We'll be very safe. And then I'm betting that we have better indoor air quality than those other guys because we're traditionally a more intimate group. But we'll be talking about a number of reports of education-related stuff going on, and then having discussions about this, BEM Career Pathways Initiative, the project that Nick mentioned. So if you're interested in giving input to that project, which is underway, join us. We'll talk about this project proposal, quantifying BEM employment opportunities, so also you can give input there. And then we'll probably have a discussion about growing the workforce for building performance simulation in the age of AI. So Professor Kolderup, who you'll also hear from today, has some thoughts on work we might do in that area. And of course, we'll be talking about artificial intelligence applications. So join us. And now we'll invite the co-chairs for Working Group 3. Again, I don't know why you'd want to listen to them because we're going to be doing more interesting stuff, but let's give them a chance. Okay, thanks.
So thank you, and bear with me as we stand in for this. So Working Group 3, we focus on advancing capabilities and metrics in building energy modeling for in and outside of compliance modeling. What are we doing first? Activities for Working Group 3. So over the last year, as if we didn't do the traditional webinars, all the groups have mentioned, we did kind of these cross-pollination webinars where we brought all the working groups together, all the working group members together in these cross-cutting topics. So we had that towards the middle of the year. We had a couple of those. In the January webinar, we had a review of project ideas that came out of 2024's CalBEM. And we kind of tried to prioritize which ones should be the focus of this past year that's gone through and try to develop some of those into proposals, two of which have turned into them. One is mentioned in Working Group 2, the BEM Career Pathways project, and the second one, a project on complex HVAC examples, which was born out of a frustration on guidance and some systems not being modeled as you would want, or people not being sure how to model certain systems in certain project designs, and trying to provide things about what is technically possible in the compliance software and how do you actually do it, and provide some guidance in that way. So not trying to tackle systems that are not possible and people are doing workarounds for. That was definitely a hot topic of that discussion, and won't be a focus of that. We are going to document those examples, but not really cover them. I'll hand over to Haile just for this cross-pollination because he did that one.
Good morning, everyone. So we did have a cross-pollination meeting in May, and this was focused on building energy modeling and accuracy of building energy modeling, what could be done in models and what can't. Obviously, I was on this discussion really focusing on how the Energy Commission software works, the limitations there, and what we are really focusing on the software. Neal also was presenting, looking at specific case studies about modeling software and how that compared to actual building performance and what trying to identify differences between the two and what caused those differences. And Gary Collins also rounded out that discussion regarding compliance modeling software and the differences and the performance issues, the performance differences between that modeling software and what ultimately came out. We had a lot of feedback from the different participants of that group looking at one, is it a problem that compliance software really looks at compliance and does not look at building performance, which was a resounding yes. Again, there are some limitations that we have from the policy side of things, but really trying to figure out the best way to increase modeling performance. We also looked at identifying some of the areas where where modeling can be improved to help bring into alignment the compliance modeling as well as actual performance of the building, looking at things like the performance credits that are being looked at, and again, really identifying the lack of flexibility in scheduling and other sources that results in that divergence between the two. And then with that, you want to?
Yeah. So a quick update on this project, as I mentioned briefly in the intro, for something that was successfully awarded this past year. So the compliance software can prove to be extremely challenging to utilize properly when configuring HVAC systems in multifamily and non-residential buildings. So the focus was on non-residential commercial applications. It wasn't to do residential modeling. And the project's focus is to create resources and examples of those complex HVAC systems, which can help design professionals to accurately use compliance software components available in the software building on the existing set of system examples CBEC includes. So this project does have a few steps to go through, which I think are on the next slide, which are to like survey the existing resources available, making sure there's no duplicative effort, making sure we're documenting exactly what resources are around, because maybe some of the example models are there and people just don't know where to look for them to find. But once we've determined the actual problems that have gaps, the models and systems that aren't quantified, to try and develop a selection of 5 to 10 of those systems, depending on how much repeatability there is between those types, and prioritize that with a technical advisory group, which does plan to meet fairly early in the next year, in February, and we are looking for members to join that tag from the symposium too. So if you want to come to Working Group 3 and talk about this project and be part of that tag, that'd be great. The second part of the project is developing those resource materials, which will include not only just like example model files, but guides on how to build the system from nothing to something, and also trying to think about a practitioner who receives a design documentation for a project, like drawing sets, and has to translate that into a model, and doesn't know exactly what the system is and what it's built out of, and what those pieces in the 1 page of MEP drawing they get translate into a model file that actually has lots of different components and how they're supposed to be plumbed together. And so part of the project will also try and develop a guide that will try to link the characteristics of building HVAC systems and like tie like nomenclature to things you would find in a design drawing to things in the model. So there's like a common language people can use when they're trying to use these resources as well. And then the last piece, which is kind of very important, is to make sure people know that this is a thing and it's going on and where to find the resources. So there's going to be a lot of engagement with the industry and reporting out about the project to make sure that when the resources are available, people are taking the time to have a look at and get eyes on the project. We didn't have an agenda slide, so I'll try it from memory. So we're not promoting, don't come to see us. We're too hard to find, as Erik said. But if you can find your way lost, maybe in some other floor, you might find us there. We will be talking about a new prototype building for covered processes. If Garth Torpestedt is here in the room, he will be presenting in the session 1 this afternoon. And then we basically have a kind of an open free-form discussion for the afternoon session on past topics we've covered and dropped, and then some new ideas either from this symposium, the talks this morning we're about to hear, to like broach our discussion into an AI topic that everyone else is trying to touch on, but we're going to approach it from the capabilities and accuracy side of modeling. And then tomorrow we have Energy Solutions presenting on technical specifications and prioritized measure lists. If Krishna and Shalji are around, they'll be doing that in tomorrow's session. And then the second half session tomorrow will be wrapping up those open discussions on past and new topics and trying to develop a plan for 2026. Yes, that is the year, 2026, right? And that's it. Hand back to Elise.
All right, so everyone should be an expert on what every working group is working on now. And I promise if you can make it to the 3rd floor, you will be able to find working groups 1 and 3. There are signs up, don't be scared. With that, we're going to take a short break, and we're actually back on.